going to do a graphing review. So most of the things actually I think everything that we'll do today you have done last year in advanced algebra, but it's been a long summer, so we just want to brush up on some of those topics. We're going to be looking at graphing linear equations and linear inequalities. So the first thing we're going to look at, you guys are probably going to look at and say, yeah, that's really easy, Miss Using. I got it, no problem. Graphing from slope-intercept form. And you guys either saw this as mx plus b, or you might have looked at it as y equals a plus bx, all sorts of different letters with the coefficient next to the x either coming in as the first term or the second term here. But you guys remember what's next to that x, that's your slope, and that constant is your y-intercept. And again, you don't have to write all of this. If you know that, you should just look at this and say, okay, this is easy. That's not next to the x, so this is my y-intercept, and this here is my slope. So our y-intercept of 4, 1, 2, 3, 4, and our slope is negative 1/2. So again, a negative, instead of going up, we'll go down 1 and over 2, because hopefully you remember those R words with slope, rise over run. So you can connect those, and there we have our graph. Now the form that you might need a reminder of is standard form. We write standard form as ax plus by equals c, and where these are usually integers here. So last year I think you talked about it as the cover-up method. You can graph this from intercepts, where you find your x-intercept, because that's easy, y is 0, because again when you're looking at that coordinate plane here, your x-intercept, that's the coordinate is x and 0, and your y-intercept, where it crosses the y line, is 0 and some y. So you can get these by plugging them in. So when we have 2x plus 5y equals 14, I usually think of it as your x-intercept, so we have x comma 0, and your y-intercept, so you have 0 comma y. So to find your x-intercept, y is 0. So we have 2x plus 5 times 0 equals 14. Well, we have 2x equals 14, so our x-intercept is 7. And our y-intercept, we would have 2 times 0 plus 5y equals 14. So 5y equals 14, divide by 5, so we have 14/5. Oh, well, that's pretty close to 3, so a little less than 3 there. Now, and you could graph just the x and y and connect those. Again, you guys said the cover-up method. So a lot of people just said, well, you cover this up, and then you figure out what 5y equals 14, and you cover up the y, 2x equals 14, and you get the 7. So there's that quick method. Now, ones that aren't directly in either form, you could do either way. So if we were to rewrite this in standard form, x plus 2y equal let's back that up there, got ahead of myself, minus 4 equals 0. We'll add 4 to each side. So you have x plus 2y equals 4. So for our x-intercept, we cover up the y, so we have just x equals 4. For our y-intercept, we cover up the x's, so we have 2y equals 4, so y equals 2. So we have y equals 2, 1, 2, 3, 4. Well, that's nice and easy. But slope-intercept seems to be our default. I think that's the first thing we taught you in algebra, so we always tend to go back to that. And we say to put it into slope-intercept, we have to solve for y. Well, so once again, we can add the 4. So now we have x plus 2y equals 4. Well, we subtract that x. So now we have 2y equals 4 minus x. And now we have to divide everything by 2. So we have y equals 2, and I really know this is 1x, so I like to put that fraction out in front for our slope, so minus 1/2 x. And you'll see we get the same thing. Our y-intercept is 2, down 1 over 2, down 1 over 2, and we have the same line. Now, linear inequalities. If you guys remember, these are inequality symbols, and this one makes a dashed line, and this one makes a solid line. So we either have dashed or solid, but we have shading as well. So those symbols mean we have to do a little bit extra. So we graph it just like the equation. X is less than or equal to 2. Well, here's that line where x equals 2 right here. This is a solid line, so we can draw our line all the way up and down. And we want to shade where x is less. Well, that's easy. X is less over here. So when we look at this one, there's the two methods we could graph this in. We could graph it, turn it into slope, intercept, or we could graph it from standard. And I look at this one and I say, well, I'm going to do standard. So we got x equals 8, negative 2y equals 8. So this would be y equals negative 4. So we have the line 1, 2, 3, 4, and then out at 8. A quick reminder on this one, if you were to solve this for y, we subtract our x, so negative 2y is less than 8 minus x. But hopefully you remember from last year, when you divide by a negative, you have to switch the sign. So we have y is greater than negative 4 plus 1/2 x. And you'd get that exact same line there. So either way, you'll have points. The line will be the same, but it's dashed. And then to figure out where to graph, you have to do a test point here. So let's test point, and let's test 0, 0. So 0 minus 2 times 0 is less than 8. Well, 0 is less than 8. Well, that's a true statement. So here's 0, 0, and it's true, so we'll shade on this side of the line. So our last thing, everybody's favorites, we're going to take a look at a word problem here. A small craft business makes red trim baskets and blue trim baskets. Each blue trim basket requires 2 feet of ribbon, and each red trim basket requires 1 foot of ribbon. The company wants to use between 54 and 72 feet of ribbon each day. Let X represent the number of blue trim baskets and Y represent the number of red trim baskets. Write inequalities and graph a model that models the combination that can be made. Well, let's see. So blue goes with 2, so I'm going to put blue is 2 and red is 1. And the company wants to use between 54 and 70, switching sides here, 54 and 72. Okay, well, let's say that this is X and Y. So we know our ribbon used is 2 for each X plus 1 for each Y. And we know it has to be greater than 54. But we also know that ribbon has to be less than 72. So when we graph this one, we don't need all 4 quadrants. And I'm going to look at these and I'm going to say, hey, I'm going to do this in standard form because that's pretty easy here. So this top one here, let's see, we have 2x equals 54, 1y equals 54. And if we divide by 2, we have x equals 27. And this one we'd have 2x equals 72, 1y equals 72. So this would be x equals 36 and 72. Well, I'm just going to count by tens. 10, 20, 30, 40. And y's you have to get up to 72. So 10, 20, 30, 40, 50. This is a very rough graph. 60, 70, 80. So this first one, we have x equals 27, y equals 36. So here's this line. And then for our next one, we have x equals 36 and y equals 72. And it can be in between those. So we would shade in between. So any coordinate in here represents a number of baskets that can be made. So your assignment is right here, and there should be a piece of graph paper right behind it that you can graph with.